Okay, folks, so if you have gone to the website in the last, well, since this morning, really. So this is the stuff that I want to get through today. And I've also put up the specification, as I was just saying there, for the first assignment. And I hope to talk through that as well at the end of the back end of today's lecture. If I don't get through all of it, then I'll pick up the story on Thursday with you. So this is the focus for now anyway. And really, this is a continuation of what we were doing last week. So there'll be a little bit more on routing and a little bit more on design patterns. The lab is as expected. So you should be up to part 3 now this week. And there's only one more part in the series of labs on the Movies app, which will be next week. And then you have the basis for the first assignment. There's a fairly significant archive with this week's lecture as well. So let's walk our way through these slides here. Okay, so as I've said, a little bit more on routing today, a little bit more on design patterns. This topic here, custom hooks, I meant to cover last week, but for some reason I just seem to skip over them. So I'll come back to it this week. And then we'll talk about the assignment at the end. So we've gone through a whole series of samples now demonstrating different aspects of this React router library, which is a separate library from the React framework itself. And it takes care of all navigation or routing aspects to our React app. In other words, we want to be able to give the impression that our React app has multiple pages in it, even though it doesn't. And the impression that we'll get is, as the user clicks on hyperlinks, then the URL in the browser changes, and that causes what is displayed on the screen to change. So we have this impression of moving from page to page or from view to view. And the React Router library manages all of that for us. So I'm just going to kind of dive in really to the next sample in the series of samples. And it's this ability to programmatically implement navigation. Up to now, the only way we can achieve navigation within our React app is by means of some hyperlink. Having a hyperlink implemented using the link component that comes with the library, as opposed to the HTML native anchor tag, although you could use that as well in some cases. But that's the only way right now that we can have navigation in our React app. Sometimes, though, you'd like to be able to implement navigation programmatically. So maybe there's a little piece of JavaScript code within one of your components. Maybe that JavaScript code is triggered by the user interacting some way with the app, clicking a button or whatever, which causes an event handler to execute. But part of its execution might mean making a decision as to whether they should redirect the user to one view or another view. That's what I mean by programmatic navigation. So it's perform navigation actually in plain old JavaScript code. Now, it turns out there are 2 ways we can implement this, and it's a matter of choice really as to whether you pick one or the other. In some minor cases, you have to go with one of the options. So I'm just going to show you how to implement what I'm calling a declarative approach towards programmatic navigation and also an imperative approach. With the declarative approach, we actually have to have a state variable within the component that's specifically there for the purpose of achieving this programmatic navigation. And we use the React Router's own redirect component as part of the solution as well. We've actually seen this before, but we haven't talked much about it. It's pretty obvious what the redirect component does from its name. That's the declarative approach. With the imperative approach, there's a hook that comes with the React Router library called this one here, the use history hook. And that essentially gives us access to a method which allows us to effectively change the URL that is in the browser's address bar. So it allows us to change the browser's address bar URL. And of course, as before, whenever the browser's address bar URL changes, then automatically the React Router library steps in and it makes a routing decision by consulting its routing configuration. Okay, so in both cases, they're both concerned with changing the browser's URL address. The redirect does the exact same. So to demonstrate the kind of classic example of this is if you've got a website and let's say somewhere on the header, there's a register user kind of hyperlink, and the user clicks on the register user hyperlink, and I've implemented it twice here so I can demonstrate both the declarative approach and the imperative approach, but they both do the exact same. And typically when the user clicks on the register user, they're sent to a web form. Now I've left out all of the details of the web form. We're not interested in that, but they would fill out their web form and then they click the submit button or register button, whatever it is. And typically behind the scenes on clicking that register button, an event handler runs in the actual component that's behind this page and maybe communicates with the backend, and it does some validation of their registration details. And if it's happy with all of that, then typically anyway, it redirects the user typically back to, let's say, the home page. So it's this final bit here. This is what we need to implement programmatically. Okay, so let's look at how we implemented it both declaratively and imperatively. So again, if I bring in my routing samples from last week, so this is last week's archive now. And they're here. So I need to go into, as you remember from last week, I need to go into the top level index.ht, index.js, and change it to sample 8, which it happens to be at right now. So that's fine. And I'll do my npm start. And as I talked my way through there, all that's happening here is click on either one of these. They both do the exact same, brings me to here, and then submit and brings me back to the home page. So delving into the code. So the routing configuration, well, let's say here, right? Here's my home page and here are my 2 hyperlinks. And if we look at this one, this hyperlink, this is just a standard part now. It changes the URL of the browser to this. And then in our routing configuration, it says, well, if the URL is that, then mount this component. And it's this component now that I'm interested in. Similarly, for the other hyperlink, it changes the browser's URL address to that. That causes the React router to consult its configuration and matches it up with this. And the component it mounts is this component. So this component that I've highlighted and this one, they're both concerned with displaying the registration form and taking care of what happens when the user clicks the register button. So either or really, if I look at the declarative one first, which is here. So with the declarative one, you use a state variable and you use the redirect component that comes with React Router. So here's my state variable, call it anything you want to. And I've just decided to make it a Boolean, and I've decided to arbitrarily initialize it to false. That's not particularly significant. I do have a little bit of logic here in the component, which checks to see, is the current value true? So the initial loading of this page, this statement here would be false. So it simply skips over that and it just displays the registration form. Here's my button. And when the user clicks the button, it runs this local event handler. And this is the part that I'm interested in now. Here's my event handler, and I change my state variable. I change it to true. Of course, we know if we change a state variable, that causes the component to re-render, so it executes all over again. And of course, now this expression is going to be true. And what does it do? I'm returning the redirect component, and really the net effect of this statement here is to cause the browser's URL to change to this value. And of course, when the browser's URL address bar changes, well, we know what happens. The React router consults its routing configuration, which it has inside here. It has inside here. And its routing configuration says, well, if the browser's URL is equal to that, then mount the home page. Hence, I have, as a result of this statement, as a result of changing the state variable, this expression now becomes true, and I have effected my redirection programmatically, which was my objective. In the imperative approach, we use this special hook that comes with the React router called the use history hook. Essentially, this gives us access to a history of the browser's various URL addresses that it has gone through while the application was running. But apart from that, aside from that, the way we use it here now is we just call the hook, don't give it any arguments, and it returns this special object. And this object has a method in it called the push method. And what the history.push does, as its name kind of suggests, it pushes this string onto the browser's URL address bar, i.e. it changes the browser's URL address. So in a sense, that's an event that has occurred, and the React router library handles that event by, again, going back to its routing configuration to make the routing decision. So this is how I have implemented programmatic navigation using an imperative approach. And this is just the button handler as before. So it's really, you can compare that approach versus this approach. There's very little in them really, arguably, but there are two options available to you. So you can go back and look at sample 8 yourself, and we will have programmatic navigation. We'll need to use it in our Movies app, and you may need to use it yourself as well. So that's how that works. Just going to undo. That's sample 8. Sample 9, I'm actually going to leave until next week because there's a little bit involved in it, and sample 9 involves using an aspect of React that I won't cover until next week. So we'll leave that aside. So back to my slides. That's programmatic navigation. This summary page now really is a summary of all that we've learned about the React router library. So that's how it kind of fits in to what I've been doing between this week and last week. So we know the React router, it very much favors a kind of a declarative programming model. And that's particularly evidenced from, the way we define our routing configuration, which is this kind of stuff here. Arguably it's true to say that that's a declarative programming style rather than an imperative programming style. As well, it favors component composition. Well, there is composition going on. We're composing this with this component. And we also, as you know from last week, we can use the root component. We could compose it with our own components if we have nested roots, if you remember from last week. So it follows the kind of React programming model, both declarative and supporting component composition. What I mean by this third point here, that it follows the event state change re-render model. What I mean by that is anytime the browser's URL address changes, that's modeled as an event within the browser itself. And when that event occurs, it's the React Router library that handles that event. And by handling it, I mean it consults its routing configuration. And if we looked inside the React Router library, it would use state variables in there. And whenever the browser's URL address changes, the React Router library would change some of its own internal state variables. And of course, we know whenever a state variable changes in the context of a React app, then the app goes through a re-rendering process. And that's really how we manage to change what appears on the screen when the browser's URL address changes to something else. So React Router kind of respects everything that the React framework itself kind of promotes, if you like. So they're aligned, as I suppose they should be. And the React Router provides us with lots of components, which we've seen some of them. It also provides a number of hooks. We are using version 5 of the React Router. In version 4, it didn't use hooks at all. It used a different programming approach. So once the React framework introduced hooks, then the React Router team rewrote lots of the actual library itself, and it introduced special hooks into our programming model. So we've seen some of these hooks. We've just looked at the use history one. You might remember the use params hook last week allows us to access parameters within a URL address. I think we used the use location one last week as well. If not, we'll definitely be using it in next week's routing sample. And there are one or two other hooks as well, but these are the primary hooks. So that's it really. That's it about routing or navigation for today. So I'm going to park that and move on to, or move back to design patterns. Design patterns was all about this idea of standard kind of solutions to commonly reoccurring problems, if you remember, standard design solutions to commonly reoccurring problems. And the objective with all of these design patterns is to improve the reusability of elements within your application. By elements in the context of a React app, we mean components. So we like to design reusable components, whether they're reusable within the app or reusable across multiple React projects. That's what we like. We also like separation of concerns as a design idea, that each component should only be concerned with one responsibility. Tied in with that was this dry principle. We like all of our code to be dry. There's no repeating code. This is all from last week. We also said that there are two generic approaches towards achieving this dry principle, the inheritance approach versus the composition approach. And React is in favor of the composition approach. And within all of that, going back to design patterns, we said that there are three main patterns that emerged in the React community to kind of meet all of these objectives that I'm talking about: reusability, separation of concerns, dryness, et cetera, et cetera. We talked about the container pattern last week. Today, I'm just going to talk about the render props pattern. And again, I'm mentioning it today because well, it doesn't occur actually in this week's lab. It definitely occurs in next week's lab though. So what's this render props all about? Well, its objective is, as we might imagine, its objective is to try and allow you to, if you've got code that's kind of repeated are quite similar across components, then refactor that code and put that repeating code into a separate function, I guess, and somehow share it across the different parts of the application. So it's all about sharing behavior. Now, in particular, it's about sharing behavior logic that's kind of linked with state. So I'm saying that we use the pattern to share logic between components. That's fine. That doesn't tell us a whole lot, though. So the name there, render props. So it's got something to do with props. We know what props are. These are things that we pass into components. They're like parameters that we pass into a component. What we know so far is that a prop could be a piece of data. A prop could be a function where the function is passed from a parent down to a child, and the child then invokes that function whenever an event occurs. So it's kind of linked with event handling. Now, the third use case for a prop is in the context of this render props pattern. And I'm saying that a render prop is a function. It's a function prop, or it's a prop that is a function, but the purpose of the function is the component that receives this function prop, it actually invokes it for the purpose of determining what it should render. So if you've got this parent-child relationship and a parent passes a render prop down to a child, effectively the parent is telling the child what it should render. And that can be useful in some cases. It may not be everything that the child renders, but it may be part of what it renders. And therefore that child component is reusable because different parent components might pass different render props down to it. That's the kind of idea behind it. Here's a very simple kind of useless example. So here's in this component here, I'm calling the shared component. So the name tells you this is the one, this is kind of the child in our parent-child relationship. And okay, it has some logic in there, which we don't really care about. This is what it renders. So it has a div that has some sort of, does it have? It has a mouse over event handler associated with it. So whatever's inside the div, if you mouse over the div, then this function Y will execute. So that's function Y is defined up here, presumably somewhere. But here's the interesting part. Within the div, I'm calling a prop called render, and I'm calling it as a function. So whatever this function returns, that's what's actually going to be inserted in here as JSX. Let's supposing here's the parent, here's the component that's using it. And here it goes, it's calling the shared component and it's initializing the render prop with a function. But if we look at the body of the function, it's a one-liner now, so it effectively returns a span. So that span is what's going to be actually rendered up here. So here I'm showing you, this is what is generated in this particular example here. When this component executes, what it actually generates by leveraging the shared component is this piece of HTML. Yeah. So what's the point here? The point here is that this component told this component it should render a span element within the div. So the shared component receives its render logic from the consumer. We refer to the parent as the consumer as well. The name of the prop is, we've called it render. That's just a convention, right? You can call it anything you want to. I think in the lab, actually, I don't call it render. I call it something else. So render is just a conventional name. It's what the purpose of the prop is what makes it part of this render props pattern. Here's a slightly bigger example. So it's back to our filtered friends list application that we had from whatever it is, 3 weeks ago, 4 weeks ago at this stage. But I've modified it. And the way I want this application to work now is it still grabs a list of my friends, Maria, from the random user web API. but I want to have two different ways of rendering my list of friends. And there's two, I'm calling them tabs here, but they're just plain old buttons really. And if I click this button or this tab, it renders my friends like this. So it renders a friend with their name and their image. Whereas if I click this tab here, the friends are rendered this way, just their name and their email address. So the component that's generating the list of friends, somehow we need to tell it how to render each friend, depending on whether we're on this page or this page. Now the code for this is from this week's archive. Okay, this one here. So usual story, download it, unzip it, run npm install. And what you finish up with is the following. Now, just before I look at the code, if I move on to the next slide, you might remember this is the design that we had for our Filtered Friends app from a number of weeks ago, okay? And so this is the component that talks to the web API, the random user web API, gets the list of friends and passes that array down to this component. This component maps over the list of friends, and for each entry in the array of friends, it instantiates, if you like, a friend component. But back then, when we looked at this application, the relationship between filtered friends list and friend, I'm saying, was a static relationship. In other words, this component always rendered a friend in the exact same way. And that was determined by essentially the import statement at the top of this file. So it was a static relationship. But in my new version of the application, I want this relationship here to be somehow dynamic. And I want, by dynamic, we mean I want it to be determined at runtime. And the way we're going to do that is this component here is going to tell this one how it should render a friend at any particular point in time. That's how this is going to work. So on the right, what am I saying? Yeah, this is the problem is the problem that I had with this application as it was designed before. And I've just talked my way through that. So just run it. Okay, and so again, if I click on this, it renders that way. If I click on this, they render that way. The filtering works as before, so I don't need to go through that really. And in terms of the component breakdown, let's look at this one. So this is at the top of the hierarchy. This is my the component that manages the state and all of that. Yeah. So again, we needn't concern ourselves with the only new. Well, okay, that's the state variable that manages the text box. This is the state variable that stores the full list of friends returned from the web API. And this is a new state variable. This state variable is going to allow the app to know which of the tabs the user has clicked on. In other words, which of these two tabs here have they clicked on? So it's going to record that. And I've just decided to use, just a simple little string. And I change it from image to, what do I change it to? I change it to, what do I change it to? Suddenly I've forgotten how I did that. Oh, do I do it here? Oh yeah, I either set it to that or I set it to that. Okay, so it's just a string that I've used. I could have used anything. Could have used a Boolean true and false, where true means one thing and false means the other type. So, right. And you can see here, every time this component renders, I do this, right? I check to see what is the value of format. Is it equal to image? If it is equal to image, then I set this variable to friend image. And what's friend image? Friend image is the component that renders a friend as their image preceded by their name. Okay, so that's this component, which is over here. Okay, simple component, but it just renders the friend's name and their image. Sorry, I should have left the app open. So I guess this is the kind of key decision making. This is the dynamic part. This is the line that determines how should friends be rendered. So every time the user clicks on one of the tabs, or indeed any state change occurs, for every state change that occurs, this decision is made, and it either decides to use this component to determine how friends are rendered, or this one. This component is the one that just renders the friend with their, followed by their email address. And if I go down into the JSX, because all of this stuff is not interesting. This is just talking to the web API. This is just where we compute the filtered list. None of that has changed. Sorry, this is filter change. This is the one that executes when the user clicks on one of the tabs. This is the code that computes the matching list of friends. And then, moving on down, I guess the only thing that I need to highlight here is, let's see. Yeah, here is where my render prop is, because what I'm passing down via this render prop is the variable that has been computed up here. Okay, so what I'm passing down to my filtered friends list via the render prop, what I'm passing down is a reference. Let me just check that now. Sorry, I'm passing down a function, and the function returns an instance of friend, but of course friend is going to be determined by whatever I set this value up here to. Am I explaining that properly to you? I'm just checking now, sorry. Yeah, that friend there is really coming from here. Okay, so it's determining, it's passing down to filtered friends list how it wants friends to be rendered, and it's passing it down as a function. It's passing it down as a function. And who's going to call this function? This function is going to be called by our filtered friends list. So let's look at this component. We're obviously passing down the list of friends that we want to have displayed as well. And if I look at my filtered friends list component, previously we would have done this, but I've commented out. Previously, we would have statically imported how we wanted a friend to be rendered, but that's a static relationship, so that's never going to change. That's not what I want. Now what I'm doing is, as before, I am mapping over my friends Okay, here I'm mapping over my list of friends. And for each friend in the array of friends, I'm calling the render prop. And what the render prop function is going to return is going to be an instance of a friend component, but the particular type of friend component is determined by the component that I was just looking at there a few moments ago. Okay, I think if I go back and explain it all over again now, I'll only confuse you, but so you need to perhaps review that code yourselves and be familiar with this render props pattern. Just pause for a second in case I need to go back over anything that I've explained there, in case I have confused you. No. Okay, so the overarching point is, or the key point is this line here. We pass down as a prop to the child component a function. That function is going to be invoked by the child. And where is it invoked? It's invoked right here. What the function returns is a component. And what type of component is returned is actually, in our case, it's a component of type friend. But the friend component type is actually dynamically determined. And in our case, it's determined by means of this statement here. So that's this render props pattern. And there are just excerpts from what I've talked my way through. So I won't go over that slide. Right, so we looked at the containers pattern. We looked at render props. The third most common one is this higher order components function pattern, but it's not really used as much as it was before. Render props isn't used as much either as before. Containers is still used as much as before. The reason these two are not used as much as before is because of the introduction of hooks. What we used to use render props and higher order components, what we used to do, use those two patterns, the kind of problems we used to solve with them, we now solve them using hooks. And so I'm not really going to talk my way through the higher order components, A, because I don't use it in the labs, and B, because it's not as important, I suppose, as it used to be before. But technically what it is it's a function, a higher order component, despite its name it's a function that you can pass a component to, and what the function returns is an enhanced version of that component. So it both receives a component and returns a component. And the component that it returns is the component that it received, but enhanced in some way. The typical enhancements might be it makes the component stateful, or even adds state to an already stateful component. It may actually, the component that it returned may be allowed to receive more props than the component it received in the first place, or it may just simply enhance the component's UI. So these are the different kind of use cases for this higher order components approach. There is a certain amount of overlap between higher order components and render props, because render props essentially kind of does this, if you, based on the example I just showed you. But the higher order components has more possibilities or options available to it. It's a nice pattern, but as I say, there's no point in covering it if it's not really used that much anymore. And I thought I had a comment on this slide. Oh no, it's on the next one really. So this summary now is a summary of everything we've talked about in relation to patterns. And I'm not going to go over it again because I've kind of mentioned it at the outset. This point here that I was making, I've made a number of times. There is one other pattern that I need to look at, which I haven't mentioned here at all. And it is a pattern that is very common still. And so I'll reserve it for next week's lecture, because it also kind of, it works its way into the last routing sample that I need to look at. So they're kind of, they come nicely together. Now, where are we time-wise? Okay. Kind of linked to this, but mainly because I forgot it last week, is this notion of custom hooks. So we know that hooks are a really important part of the React framework now. And indeed, third-party libraries have adopted this hooks model. The React router library, as I was talking about there earlier on, it also provides us with hooks. And we can write our own hooks, which is what I'm referring to. We refer to as custom hooks. And why would we do that? And what would they allow us to do? I'm saying a custom hook would allow us to. What it allows us to do is extract component logic into reusable functions. You know, so it's all linked back to this kind of reusability, dryness, separation of concerns, etc. Ideally, we'd like our components to only have code that are directly concerned with the V part of MVC, or they're only concerned with the UI part of your React app. Any kind of logic we'd like to take out of the component and put into a separate function. Because it just cleans up our code, even though that separate function may not be reused by anywhere else in the application, it's still a good idea. Now, so what kind of logic could we extract from the kind of components we've seen up to now and put them into a custom hook? Well, the answer is any logic that's kind of linked to the notion of state. So yeah, here's a simple example. And in this week's lab, I have two examples of custom hooks. One is a simple example. The other one is arguably much more complex, but I've added it to the lab to give you a sense of the kind of possibilities that are available to us as developers for implementing our own custom hooks. I wouldn't necessarily expect you to visualize the second and advanced sample in the lab, but I would like it to gain an understanding, A, of how that hook works, and maybe B, just give you a sense of the possibilities that are available to us for developing our own custom hooks. So here's a simple example anyway. So I've got this component, and it looks like it might be from some sort of online bookstore or a library application. The name kind of tells us maybe this is a component that renders details about a book. So it's a full view for this application. And as expected, we've got a state variable. It looks like this state variable is concerned with storing the details of a particular book. This use effect more than likely is talking to some backend API that provides the data associated with the book, and we're putting the data into our state variable. So this is standard kind of stuff that we've seen already in the context of the Movies app. And this kind of logic here is about state management. That's the term I would use to describe it. It's about managing a particular part of this application's internal state. So it would be nice if we could take all of this stuff, which is quite verbose really, and just put it into a separate file. And hence this book page code is going to be cleaner looking. So in this case anyway, we can literally lift that code and put it into a separate function. And so we finish up with this. And it's almost a direct lift. Now we do need to, so this is just an ordinary function at one level. And because of what the function is concerned with, we do need to pass in the ISBN number of the particular book that may be displayed at any time, because the use effect hook is going to use it using the ISBN somewhere over here to determine what to communicate with the backend API. And other than that, it's a straightforward movement of the code from our component on the previous slide to this separate function. But because this function is using state variables, React state variables, then it's not just an ordinary function really. The whole notion of whenever the state variable change, then a component needs to re-render. Well, what component? it's going to be back to this component. It's going to need to re-render. So we should give the hook, we should give this function a name that begins with use, because you might remember when I talked about hooks originally, there was this requirement that every hook, its name had to begin with the prefix use, and that was to allow linters to check that we use the hook properly. So this is my custom hook now, and just like all other hooks, the rule with hooks is that you can only invoke them from the top level of a component. You cannot invoke them within an if statement or within a for loop. Now the same will apply with this function, this custom hook function. It can only be invoked at the very top level. And really, you know, this is how it's going to be invoked in this particular use case. So this line here is where I'm actually using my custom hook as if it was a hook provided by the library. And it is being invoked at the top level, so it's satisfying that requirement, and the linter that comes with the Create React App tool will confirm that for us. So other than that, what should a custom hook return? It's completely up to you, and it completely depends on what the hook does. You'll see in this week's lab, I have a simple hook which looks and behaves very like this, and I have a more advanced hook, in which case there's a lot going on in the advanced hook, and what it returns is specific to that hook, and it's not your standard kind of return value. But in the case of this hook, I'm returning essentially what the use state returns, but that just happens to be coincidental. Okay, use state returns these two, this tuple as it's called, and I'm actually returning the same tuple back to, in this case, this component here on the right, because presumably this component on the right, at some stage, it will want to change what book is being displayed as a result of the user interacting with the page. So it'll need to call the setBook setter method, and so it needs to have access to that setter method over here. And we need to return the current book details that are being stored inside here, because presumably within the JSX of the book page, it'll be displaying details about the book. So it's coincidental that it's returning the exact same return value as the use state, as the state variable that's being managed within this custom hook, but that is only coincidental. So the custom hook is an ordinary function at one level, but of course, it should only be used or it should only be invoked from within a React component. It only makes sense to be invoked from within a React component. And it has to follow the normal rules associated with any hook. And I think, is that all I want to cover? Prefix, yeah, I've mentioned that already. And in general, hooks, they either return an array of things or they return an object. So in both cases, they tend to return a collection, some sort of collection of values. And any hooks that we'll ever come across, that will be the case. It's when it returns an object that we're typically talking about more advanced hooks in that case. But in general, it returns a collection of values. Right, that's my introduction to custom hooks. And again, not to be repeating myself, you'll see 2 examples of it in this week's lab. So that now means I can now talk about the last topic for today. So I'm getting there a little bit earlier than I expected, which is the first assignment. If I go back to the website, I'm going to just talk my way through. I'm just going to close off some of these. Talk my way through the first assignment specification. So it should be no surprise to you that the objective of the first assignment is to take the movies app that you will have completed after next week's lab and then build on top of that. If you want to do something other than that, you need to consult with us beforehand, and we need to give you the okay. But I'd be inclined to encourage people to take the option of taking the movies app and build on that. Because if you're starting from a clean slate, you know, you are going to hit problems that may seem like trivial problems, and they will take you could take you some while to debug. Whereas when you're starting with a reasonably large code base, which you will have by the end of next week, then it's arguably anyway, it's easier to build on that rather than start from a clean slate. Anyway, the overall objective is, as I've stated here. I'm setting this as a completion date, but that's kind of arbitrary, because what you will, I think this is actually the last day of week 12, but it's kind of arbitrary, because what you will really be submitting in terms of assessment work for us is one project comprised of a front end and back end, and you won't get the back end specification until around week 10. But I guess what you should aim is to try and have most of the front end done by that date. That should be a target you should set for yourselves. And as I said, you will get the back end or assignment 2 specification around maybe week 11, and you will have about 4 weeks to work on that. And so hopefully you already have your front end now ready to hook into your back end. I'm saying that this, of the 2 assignments, this is worth 60%. The reason it's not a straightforward 50-50 split is because some of the requirements that I have included in this specification really relate to the back end, and I'll explain that later on. So the 60% here is inclusive of some stuff that will really be part of what your back end development, it's where it'll be implemented, but of course you need to integrate your front end and back end. So that back end code will need to be part of your front end implementation as well. In terms of deliverables, really all you'll be submitting to us is a GitHub repo or repos. You'll probably have 2 GitHub repositories, one for your front end, one for your back end. And you'll also submit a short video where you demonstrate, short YouTube video where you demonstrate your working application. And we may well interview people either face-to-face or over Zoom, probably face-to-face at this stage, given that all COVID restrictions have now been removed. We'll be interviewing you to talk about your submission. Here I'm just saying that we will provide the exact contents of the README for both of your GitHub repositories. And it's very important that you follow the template that we provide you with, because we use the contents of the README to make an initial assessment of the standard of your submission. The second point, and I need to reformat it a little bit better because it's not standing out, but the second point is this bit here, okay? It is really, really, really important that you maintain a Git log of, as you progress your way through our projects. So essentially, I'm saying that every single time you sit down and start working on, be it the front end project or the back end project, every single time you should do a commit. If you're working for half an hour on it, do a commit, and in the commit message, just summarize what you were working on. If you sit down and work for 3 hours back to back, then I would suggest maybe you should commit at least twice during that period of time. But we do require a Git log or a Git history of your work as you progress through an assignment. Please do not say to us at the end, gosh, I forgot to do my Git commits as often as I should have, unfortunately, that won't wash. That is like coming out of an exam and saying, I knew all the answers to the questions, but I didn't actually write down the answers that I meant to, you know, and I don't want to be disrespectful now, but so you've got to remember to do git commits very regularly. Right, enough for the lecturing. So here's a kind of a grading spectrum, and you should really keep an eye on this as well, because this is what we will use at the end of the day to assess your work. And so I'm trying to give you some ideas as to what you should be doing for this particular assignment. So if you're aiming between this grade band here, and just before I start talking my way through that, maybe what I'm going to do is I'm going to start up the Movies app, because it's going to help me to explain certain things to you. So this is what the Movies app is going to look like at the end of next week. We're not too far away from that, actually, even from week 2, and we know how this thing works. Okay, right. So we've got our list of movies from what I'm calling the Discover endpoint, and we also have the ability to display details on a particular movie. So back to my specification. I'm saying for the 40 to 55, what we'd be looking for is that you add some more what I'm calling data list pages. Now at the moment, the app has 2 data list pages. It has the list of what we call the list of Discover movies. And we also have the favorites page, which is another kind of data list page, if you like. We know how this works. If I select some favorites, then I get the other list page. That's fine. So now what are some examples? Well, at this stage now, maybe I could just look at TMDB itself. And in the second page here in this specification, I talk about TMDB. I don't know if you've looked at the documentation behind it or not. So if you click on this link, it'll bring you to the TMDB docs page. And TMDB as a web API, it provides a number of what are called endpoints. And the endpoints that we've used so far is we've used the Discover endpoint to get the list of movies. That's the endpoint that gives us, where did my app go? That gives us the list that we get on the home page. And if I actually looked at the code, then I go into here. Now you should be familiar with this from the labs. Here's where we get movies. And if we look at the actual URL, then like there's the Discover part. That's telling me that I'm using the Discover endpoint from TMDB. So we're using that. just going to skip over that for the moment. Where else do I want to go now? I want to go back to here. So what are other examples? I'm saying there are other examples of endpoints that gives us a list of things. So there is the top rated endpoint that gives a list of top rated movies. There's a similar, there's a similar movies endpoint. Now, where's that? I wonder if I go into the docs. And on the left-hand side here, it's where you get all of the various endpoints, and it obviously documents them. So if I scroll down, I can get more details on the discover endpoint there. So it tells me something about how to use it. This is the URL that you have to use. And that's kind of consistent with, I know I'm jumping around now, but that's consistent with what I have here. And of course, there is a query string part as well, which we'll come back to. The other interesting one that we've looked at is the movies endpoint. And if I scroll down and find that, here's the movies endpoint. And it has lots of options available to us. They're all HTTP GET requests. But if I skim down through them, and if I pick out this one here, get similar movies. If I click on that, so /movies / a movie ID / similar, that request will return a list of movies that are similar to the movie whose ID is whatever you give it. It's obviously a parameterized URL. And so this endpoint returns a list of movies. Now we already have some component code that allows us to display a list of movies. So it wouldn't be a massive jump to maybe have the following type of behavior. Once I go into the detailed page for a movie, maybe there might be some sort of hyperlink or button here, which is similar movies. And when I click on that, my React app will make an API call to this endpoint, get back a list of movies, and then I could have a page that displays that list of movies. And the page really would be, in structure, would be the exact same as this page, except it would have a different heading, obviously, maybe similar movies to whatever movie you were looking at just a moment ago. So we have all the knowledge now to actually be able to produce that. That's another example of a data listing page that we could add to our app. What else do I talk about? I talk about a list of actors, just in general, not actors linked to a particular movie now. And so can TMDB provide me with a list of actors? Well, if I look down through the left-hand side, if you go to the people section, it doesn't have an actors as it turns out, but people and get details, get current changes. This should be in there somewhere, I think. Should have checked beforehand. Well, you can get, let's see, sorry. So maybe there isn't a straightforward get all actors. There is this one here. Where is it? Get movie credits. If I click on that one, so get /person ID /movie. That's actually not good to me. Let me go back to movies, actually. I sort of went off an incorrect tangent there. If I go back to movies and get credits, what get credits does is it returns a list of all of the people linked to the movie, and it categorizes people as either being cast, as in they were acting, or crew, as in they were part of the production team. And I guess the cast is all we would be interested in. So if you send a GET request to this URL and you already have the movie ID from your movie details page, and if you look at the structure of the data that comes back, and you always need to check the structure of the data that comes back, it'll be an object in this case, I remember. And one of the keys in that object will be cast, and cast will be assigned an array. And the array will be an array of actors' IDs and maybe their names and a small amount of information about them. Now, once you have an actor's ID, you can then go to the people's section and get details on that actor. So with that knowledge, we could do something like, from the details page again, we might have some sort of link here to say show cast. When I click that, maybe I can get a list of images of each cast member and maybe just their name and maybe one detail about them. And clicking on one of those cast members, it would bring me to a page whose structure could be the exact same as this. Maybe some images of them on the left and some various details about them here, their name appearing here. So we could use this overall kind of template for actor. Well, could we? Maybe not. We probably would need a different template because the kind of details are very different. So what I'm kind of get at there is, you know, there's lots of these endpoints that would allow us to satisfy this requirement of additional data list pages or views. Movie cast, well, that's what I've just been talking about. Actor details, we can get the details about a particular actor from no, got onto here. From here. Okay, so that's a bit like getting a movie's details. This is getting a person's details. And so you can play around with that to come up with a couple of different both data list pages and I suppose detailed pages as well. I'm specifically specifying list here, but the top rated movies, there was an endpoint for that actually. If I could just go back to, I don't think it's within movies, or maybe it is, maybe I just check it. It's never a good idea to explore these things as you're presenting, but so forgive me for that.
Second last.
Is it there? Get
second last.
Second last. Oh yeah. Well, that's top rated. That's of all time. Get upcoming. Yeah, you can browse through them yourself. Is it there? I'm not seeing it now. Top rated is. Is that what I said on the? Maybe that's what I said. Top rated is top rated for all time. But as I was scanning it there, you can also get. Well, I talked about similar movies. You can get recommended. Where's recommended? Why am I not seeing these things clearly?
At the top, just above recommendation.
There we go. There's a slight difference between recommendations and similar, but again, that's going to return a list of things, in this case, movies. There's lots of possibilities there, and you can use whichever ones you want to. You don't have to use all of them, obviously. Let's move on. Next thing is in order to get into the 40 to 55, I'm saying I have multi-criteria filtering and sorting. Now I'll go back to my movies app. And if I go back to the home page, at the moment, I'm filtering just on the basis of title and genre. But you could filter, you could add in one or two other criteria yourselves here and just follow through on that. Similarly for sorting, I don't have any sorting criteria, but you'd pick any criteria that you want to. So it could be based on movie rating or whatever, and just implement the sorting of this list of movies every time the user changes any of these. So we should know how to do all of that at the moment, and we could actually you could add that straight away without ever looking at the other endpoints. Just be able to sort this list of Discover movies on different criteria. Rating would be an obvious one of them, maybe popularity, which I don't display here, or some other criteria. So augment that filtering and sorting in order to get into the 40 to 50 category. Routing have a mixture of static and parameterized routes. So if you had a detailed page about an actor, that would be an example of a parameterized route. If you had a list of movies that were similar to a movie, that would be another example of a parameterized route, because presumably the URL for that particular page would have to have the movie ID linked to the list that are similar to that movie. And as well, have lots of hyperlinking between the various pages. The only hyperlinking we have at the moment is the ability to go from here into here. But if I had a list of the cast, then they should be hyperlinked, so I can go to a detailed page for that cast member. If I had a list of recommended movies, then obviously they should be hyperlinked to bring me back to this page, but show me details of that movie. So always avail of hyperlinking because it's a significant core part of the web. By TMDB integration, I just want to see that you have used a few of the other endpoints, some of which I've mentioned there. So I'm roughly, you should be roughly using 4 more endpoints over and above what you will have used having completed the lab. If you will have, I can't discuss this because I'm covering caching next week. So you'll be able to make sense of that after we talk about it next week. In terms of storybook support, any new components that you will have developed, then just write a story, at least one story about them. So you can demonstrate that you have used Storybook and you know how to use it. So that's that bracket. In the 55 to 75, I'm talking about, I'm really talking about adding new types of pages and new types of functionality. Arguably, what I've been talking about up here is replicating what you already know. Lists of things, details about a particular thing, whether the thing be a movie or an actor. Whereas down here now, we're going to have to develop our own types of pages. And I am being specific, although I do say at the bottom here, if you have some other ideas, then feel free to develop components and pages around those. But specifically, I'm saying it would be nice if we had the ability to add my fantasy movie to the movie database. Now, you won't be able to add anything to the TMDB database, obviously. So your fantasy movie, the details of it will be stored locally within the browser. And ultimately, when you develop a web API with Frank, you'll be storing it in a database. So what am I getting at there? So we'd like to have, we need a web form, obviously. Expanding on it down here, I'm referring to asterisk 1, and asterisk 1 here talks about, there's a lot of information about a movie that TMDB stores, and there's too much information really. I'm just limiting, let's say, You need to store what title you want to give the movie. Where am I detailing? Yeah, just the title that you want to give the movie, an overview of it, the genres that you would categorize it under, its release date, Maria. So the nice thing there would be if you had actually a date picker. There are date picker components, third-party components out there, or else you could just enter the date as a text string. Obviously, that wouldn't be as user-friendly, but you can Google around date picker. You might come across a nice one. Runtime, you know, I guess you should do some basic validation that it's something sensible in terms of minutes. And it would be nice if you could upload an image or a poster Maria linked to. You can just randomly pick any image you want to, or images. So image upload, there are third-party components that handle image upload for you. See if you come across one and try and stitch it into your solution. Overall, in order to be able to do these things, we need to know how to implement a web form. And when you complete next week's lab, you will have, in the labs anyway, you'll have this ability to write your own reviews about a movie. And the way we'll access it is from the favorites page. Again, we'll have this completed by next week. But in the favorites page, there's going to be, each card is going to have this icon. And if I click on it, it brings me to a web form that allows me to publish my review. Now, the reviews are actually still only going to be stored within your browser. You cannot store them in TMDB, but when you develop your web API with Frank, you will be able to store these reviews in a database owned by you. So I guess we'd enter our name here. Here's a text area where we could put our review script, and I have an example of a drop-down menu where I can just rate it. Okay, and there are some other controls like maybe checkboxes or other types of controls. Now I'm using a third-party library to produce this web form, a library called React Hook Forms. So we'll see that next week, and then you'll be able to use that third-party library for your web form that will allow you to input your fantasy movie. Now, the slightly hard part though is how do I add actors to my movie? I can leave it open-ended, but for example, the way you could approach it is, so let's supposing this is my web form for setting up my fantasy movie, and I might have another page then where it just shows me my fantasy movie in a similar way to, let's say, the movie details page. This is me just thinking out loud now. So this might be, instead of, you know, the movie details page, this would be specifically your movie details page. But maybe there may be a button here, add actor. And when I click on add actor, I get a page that displays a list of actors. And the actors might have an icon. And if I click on that icon, the effect of that is to add that actor to my movie. So it's a bit like tagging movies as your favorites. You could use that approach. I'm only suggesting this now. You might have a different approach, and it might be a much better approach. But we don't want to be entering actors' names as text. We want to have some ability to select them. You could have a drop-down menu, but that wouldn't be great either. You know, a list of, 100 actors. You could limit it if you want to, if you can't take the approach I'm suggesting. So that kind of tagging idea might be how you'd add an actor. You'd have to think about that really as to A, how you'd like it to work, and B, are you able to actually implement it or not? So that is a bit tricky, admittedly. That's the fantasy movie feature. The second feature I'm calling is a multi-criteria search. Obviously, what I'm trying to get at here is have this ability to search for a movie based on certain characteristics or qualities or criteria associated with the movie. Slightly different from filtering now. And yeah, slightly different from filtering. Now, TMDB actually can help us with that. And if I go back to, let's see, if I go back to here, and I go to the discovery endpoint, and if I also bring up in my code where I use the discovery endpoint, which is here. Now, if I scan across, also maybe make it a little bit bigger. So this part of the URL is what we call the query string, anything after the question mark. And we know we have to include the API key. But if we keep moving across here, you can see that the query string has some other options available to us as well. So clearly this part here is saying I only want movies that are based on US English language. So I don't want foreign language movies for whatever reason. I'm also saying, just to keep it clean, I only want movies that would not be classified as adult movies. So there are two options that we can include on the query string when we're talking to the discovery endpoint. Now, if I go back to the documentation, it turns out that there are many other options available to us, and they're being documented here. So here's the query, tells us about the query string, and it's listing them all down here. So, and there's a total of, does it tell? It tells us somewhere. Okay, look, there's a total of 37 options. Now, just pick a subset of those, 5, let's say. And the idea then is that if we had a web form, so we're back to our web form again, and the web form would allow us to select values for those 5 options that we've decided to pick from this list of 37. We enter values for those options, whether we enter it as text or as some sort of drop-down menu, depending on what's appropriate. Click submit. Now, when we click submit, in our code, what we will have to do is essentially construct this query string here programmatically. Okay, so it's just going to be some sort of string concatenation. Construct the query string over here. Construct it programmatically and, you know, take the results that comes back from TMDB. It's always going to return back an array of movies. It obviously won't be, well, yeah, it'll be an array of movies. So you have to see if you could actually achieve that. And that would be an example of a movie search, multi-criteria search, movie search feature. So it's based on using the discovery endpoint. If you look at the docs again, there is where am I? There is a search here, but I don't think it's any use. And anyway, I don't want you using that. I want you to implement your own search. And I'm kind of telling you, use the discovery endpoint as the basis for your solution. Pagination is the next thing on my list. Now, again, if I go to my code, and if I keep scanning across here, you will see at the very end, there is a page. There is a page option, and we have hard-coded it to 1. So it turns out that the discovery endpoint and some of the other endpoints that return lists of things, they're actually already paginated endpoints. And so we can specify a page number. I think if you don't specify a page number, then it defaults to 1, obviously enough. But pagination is built into certainly to the discovery endpoint. And that would mean that ideally in our, if we go back to what we have at the moment in our app, ideally we would like maybe at the bottom of this page to have your standard kind of pagination links, page 1, 2, 3, 4, next and previous and all of that. Now there is also a third-party React pagination component that will handle the UI part of that for you. In terms of talking to our backend then, well, in very simple terms, I suppose it might mean instead of hard coding this to be 1, instead of hard coding it to be 1, maybe we could pass in a page number as an argument to this function here, and so make it more adaptable. You can kind of look around that yourselves, but pagination is automatically built into the discovery endpoint, and you wouldn't really need to implement pagination anywhere else. You could if you wanted to, but as long as you manage to implement pagination for, let's say, the home page, then that would suffice as showing me that you were able to solve that particular problem. We'll come across pagination next week as well in relation to caching, so we can come back to that. But for now, what I'm showing you here is where you should be looking at to try and satisfy that pagination requirement from the spec. So there's 2 parts that really, there's one just the UI part of it, and I am advising maybe that you should just do a Google search on React pagination third-party library, and you will get one that takes care of that. But you've got to hook that or connect that library to your code, and by your code I mean, you know, this kind of stuff here. So and as well, if there's any new storybook stuff, that just make sure you write at least one story for not necessarily every single component, new component that you develop, but for some of them anyway. So I'm not understating now how these are challenging. Okay, I don't deny that they will require you to spend some time poking around with TMDB and poking around with React. And you may not be, don't aim for perfection. We're only looking for prototype standard stuff. So if the UI part of your implementation is a bit clunky, I wouldn't be too concerned about that. Try and clean it up as much as you can, but the main objective is to try and get these working to some degree anyway. Cleaning it up and making it look beautiful is something you would do, or any software engineer would do after getting it basically working. And I'm only looking for the basic workings of it. I'm not looking for perfection in terms of the UI side. So there's a lot to grind on there, really. And so I think I've spoken about that. I've spoken about that. And in relation to the pagination, there is this third-party library called React Query, which I will cover next week, and that has a pagination side to it as well. But you don't need to know anything about React Query in order to get basic pagination working, as I have explained it there a few moments ago. So if you manage to get, you know, most of this kind of stuff thereabouts working, then you're into that 55 to 75 bracket. And again, we're not looking for perfection. We're looking for prototype standard functionality. To move into the 75 to 85. Now, this is the stuff from here on in now. I'm really talking about functionality that really would reside at the back end. So you can't really tackle any of this stuff until you have worked your way through some of the material that Frank will cover with you in the latter weeks. But just for now, what are we saying? We'd like to have persistence and session management within our app. Well, by persistence would mean we'd like to store our fantasy movie details in a database, which Frank will look at. We'd like to store, what else? Is that the main one? Any other, I guess maybe your favorites. If you tag movies as your favorites, we'd like to store those in a database, because at the moment, once we refresh our React app, we've lost all our favorites collections. So some element of persistence needs to be built into the app by session management. That's obviously linked with authentication. At the moment, anybody can use any part of our app, but maybe in a production standard app, in order to, let's say, set up your movie, your fantasy movie, and select your favorites, you first of all have to be a registered user, and you have to log in to the React app. Frank will cover authentication from the backend point of view, because it's the backend that's going to manage all of that for us. He will show you how to implement authentication and session management from the backend point of view, and he will also show you how to integrate it with your front end. So you cannot tackle that until he covers that material. So that gets you into the 75 to 85. So that's really all about integrating your React app with your web API as opposed to TMDB. And the last piece of the jigsaw, if you want to move into this bracket, is where we ask you to implement a particular piece of business logic or an algorithm. You will be able to work on this if you want to before you start the backend development, but ultimately the implementation of the algorithm and the business logic, ultimately that will reside in your web API at the back end, because any business logic should not reside at the front end. Now, I'm being specific about what business logic is a bad name. I guess algorithm is probably a slightly better name. What algorithm I would like you to implement, and it will center around having a feature that recommends movies to the user. So I'm talking about a movie recommendation algorithm. And I am saying that the algorithm should be based around movie genres. So if I've got a movie that I receive from TMDB, and it tells me this movie is associated with, you know, a couple of genres, then if the user clicks on some sort of recommended movie button on the movie details page, that will trigger the execution of your algorithm. And what your algorithm will need to do is to grab a bunch of movies from TMDB, and I'm saying you should limit it maybe to just 60 movies, because TMDB has a couple of hundred movie records in its database, so we don't want to go through all of them. Just pick, let's say, the 60 most recent movies, and I'll show you later on how you might do that. But once you've got those 60 movies, you then need to go through them looking for ones that have genres in common with the movie that we're currently looking for recommendations on. So it's just an algorithm that will just chew through those 60 movies, look at the genres associated with each of these movies, compare them to the genres of the movie that we're looking for recommendations related to. Some of the movies may have one genre in common. Some of them may have two. Some of them may not have anything in common. And so we rule out the ones with nothing in common, and we would then order the recommendations based on how many genres overlap between the movie that we're currently concerned with and the other ones that we're looking at. So it's your kind of standard recommendation idea. And I am just focusing on genres, but you may actually look at some other attributes that TMDB stores about a movie to enhance the recommendation matching that goes on there. For example, their TMDB stores keywords about each movie. And so you may also look at the keywords and see, are there keywords about one movie that also appear in another movie? And that would further enhance the relationship between those two movies. If I go back to TMDB, and if we saw it there a while ago, TMDB has a recommendation algorithm itself. And I'm just getting you to implement your own. So if we look at movies again, so sorry, the similar ones is where get similar movies, and it actually tells you here, it's basing it, it's saying it's not the same as recommended. And I think it tells you, sorry, just read it. This is not recommended. All right, it doesn't actually tell us how it computes recommended movies. Sorry, this is, which am I looking at? I'm looking at similar. I thought it said it. Oh yeah, there it says it there, actually, look. It just based similarity based around keywords and genres. And you can get the keywords linked to a movie. It's another one of these here. There we go, get keywords and get, well, we know from the movie details. From the movie details, it contains the list of genres. So you have your genres there. And you can bring in keywords as well if you want to. So what I'm calling a recommended algorithm is corresponds to similar in TMDB terms. So that might be a way of actually checking to see whether your recommendation algorithm works or not. Although admittedly now TMDB's similar movies endpoint probably goes through a wider scope of all of the movies, whereas I'm only telling you to look at, let's say, the 60 most recent ones. But it might give you an indication as to whether your algorithm is working correctly or not. And if you want to, you can broaden it. You can go broader than just genre and keywords. I'm sure you may have other good ideas as to how you might improve the accuracy of the recommendations, basically by looking at some other attributes about a movie that could enhance the accuracy. You could take that option, or alternatively, you could compare actors. So if I have an actor's detail page, there might be a button which is comparable actors, and that clicking that button would trigger our algorithm back in our web API that gets 60 other actors, just sticking with that number 60, and also looks at that actor's I think it's genres as well, it's called in the case of actors. When you get the details of an actor, you get the list of genres that they're noted for. And so again, we're comparing genres. Sorry, let me think, is that how it works? No, sorry. The way it would work is when you get details of an actor, you can get a list of all of the movies that actor has performed in. And from those movies, you would get the genres linked to those movies. So you now have genres of movies that an actor is associated with. Then you go looking for other actors, look at their movies and see the genres of that actor's movies, are they linked to the actor that we're looking for comparisons to. So it's a little bit more involved. There's two levels of indirection, if you like. So you could take one or other of those as your way of satisfying this algorithm's requirement that I'm specifying here. And where are we time-wise? Okay, there is just one thing that I wanted to show you. So I'm saying there to get 60 movies, let's say, if we go back to the recommendation algorithm, and that would mean, if you like, calling the discovery endpoint with page 1, page 2, and page 3. By the way, each page from the discovery endpoint returns 20 movies. So if I call it 3 times with a different page number, then I have 60 movies. And I guess that would mean, you know, calling fetch 3 times, but because fetch is an asynchronous function, it's not simply calling fetch 3 times in sequence. You'd have to probably nest one fetch inside the other. Now, what I mean by that is, I've played with it a little bit earlier just to show you an outline of it. Literally now, this is a long way down the line because you won't be going near this algorithm anytime soon. You'll be trying to satisfy the other requirements first. But if I just give you an indication of what I'm trying to get at. I'm just going to check out this other branch. And I'm going to start my React app again. So the version of the app that I'm starting, of the movies app that I'm starting here now, is equivalent to, it's equivalent to what you would have completed from last week, I think. Let me think, is that right? I think it's what you would have completed from, I can tell from the branch name actually. Yeah, it's what you would have completed from last week. And if I look at where I talk to the discovery endpoint from that code, well, it is inside here. Okay, so here's my get movies, and this should look, I've made one tiny change to it. I've declared a local variable called movies, which is initialized to an empty array. I do my fetch, and in here, then I just, I take the data that comes back, and you should know already that JSON.results here now is actually going to have the array of movies returned by TMDB, and I have specified page 1 of the discovery. So it's going to give me the 20 most recent movies, if you like. And I put those into my movies array that I've declared up here. And then I just return that array. And that is what we are seeing here. Here are my 20 movies. And if I open up, I think I do a console.log of it, do I? Yeah, there you see, I have my array of 20 movies. But if I want to get 40 movies, then what I need to do is I need to chain on another fetch call. And it's not as straightforward, but I've just done it earlier on so that I wouldn't mess up. And so if I just comment out that line, and if I bring in this stuff, so what I've got here now is I've got my fetch call. I'm chaining on my then clause. This one reassembles the possibly fragmented packets that come back from TMDB. And then I take all of the reassembled response that came back and do what I was just talking about there a moment ago. But I don't stop there. I now make another fetch call. And in this case, I am fetching page 2 here. And I do the same with its response. I take the results that come back and I add them to the same movies array. So my movies array should now have 40 movies in it. And if I save this change and just confirm, back to my browser, there you can see it now has, there you go, sorry, here. I now have 40 movies and we won't count them, but if we did, you can see that there's a lot more movies, certainly more than 20. And so we'd have to do another, we'd have to chain on another fetch in order to get 60 movies and so on. Now, if you're familiar, the programming model that I'm using here is based on this notion of what are called promises in JavaScript. So promises is a technique that we use to implement asynchronous communication. There is another approach, which is called the async await approach. So you may have come across it or read about it somewhere along the lines. The async await programming model is a much cleaner programming model than what I'm showing you here. And Frank will be covering both the promises programming model and the async await programming model in one of his lectures. You know, when I introduced this fetch function, I didn't really explain, I gave you an overview of what's going on here, but not a kind of a technical explanation of it. Telling you now that's based on this promises idea, a promises programming model. But the promises programming model has been kind of abstracted into a newer programming model called async await. And that is a much cleaner programming model for implementing what I'm trying to do here, which is to have a series of fetch or a series of asynchronous communications going on with a backend. All I'm doing here is just nesting stuff, and that's not really easy to follow or read. But I'm giving you an indication as to how you might grab 60 movies in order to do your recommendation algorithm, or grab 60 actors in order to do your actor comparison approach, because the actor's endpoint is also a paginated endpoint. Right. That's kind of heavy going, but where are we? So that's the spec. I'm sure you may have questions about the spec and you can pitch those at me on Thursday. And if we need to, we can start up a Zoom session